Hey everybody! So I've gone ahead and prepared a brief little tutorial that will help you with some of the math involved in figuring out problems related to solubility curves. Now a solubility curve is kind of exactly what it sounds like. You see one on the right side of your screen here. And basically it's going to tell you how temperature affects the solubility of different substances. Basically, how many grams of a substance you can dissolve in 100 grams of water. Now, since 100 grams is equal to 100 milliliters, you may see those used interchangeably. You may see either grams or milliliters of water. Traditionally, we're going to measure the volume of water that we're adding to make a solution. So often that's going to be measured milliliters. So just be aware of that small difference, but know that if you're trying to figure out the amount that you can dissolve in 100 grams of water, that's the same as what you can dissolve in 100 milliliters, since the density of water is 1 gram per milliliter. So I put a question up here on the screen that asks you how much potassium nitrate, that's KNO3, can be dissolved in 75 grams of water at 70 degrees Celsius. Now, the problem with this is that normally this graph tells us the amount we can dissolve in 100 grams or 100 milliliters of water. And so if we want to know how much can be dissolved in a different amount of water, we may need to do a little bit of quick, easy math. And so the first thing to do is to figure out, and you'll have to apologize, you'll have to excuse my weird handwriting here. So the solubility in 100 grams at that temperature is going to be found directly by looking at the graph. So if we're trying to find 70 degrees Celsius, 70 degrees, the temperature in Celsius is on the x-axis here, and 70 is right there. So traditionally, when we're reading this graph, we're going to go all the way up that 70 line until we see the curve for KNO3. KNO3 is right here in the middle. We can see that its solubility greatly increases with temperature, so if we heat it up, we can dissolve a lot more. And it looks like the solubility is right at 130 grams of KNO3 per 100 grams of water. So I'm going to go ahead and write that out exactly as I just said it. 130 grams of KNO3 in 100 grams of water. And if we want to know the amount we can dissolve in a different amount of water, it's as easy as setting up a proportion. And the proportion is going to compare the amount of KNO3 we can dissolve to the amount of water that we're dissolving it in. So on one side, we're going to have 130 grams of KNO3 over 100 grams of water. And then on the other side, we know that we're asked how much we can dissolve in 75 grams of water, so that will go on the bottom. We need to make sure the numerator and the denominator are measuring the same thing. And then we just put x on the top because that's what we're trying to solve. So our math is going to look like, because we're going to cross multiply since we have a proportion, 100 times x equals 130 times 75. And you'll have to forgive me because I misplaced my phone. Here it is. 130 times 75 is 9750. So 100 times x equals 9750. That means that x, if we divide both sides by 100, as we would to solve this, equals 97.5 grams. And it makes sense that if we have less water, we'll be able to dissolve less solute, in this case, potassium nitrate. So hopefully this quick little tutorial gives you an idea of how to solve for problems that require you to use a different amount of water than the 100 grams that are on the graph. And if you have any questions, you know where to find us. Thanks.